We talked about measuring temperature, but that's not the same as measuring energy. The more kinetic energy something has, the higher the temperature will be. But in order to measure energy, we're going to use a different unit. And you are pretty familiar with one of the units. It's called a calorie. And you know that because when you eat food, it's the energy in it is usually measured in calories. For example, we might say that an orange like this probably has about 100 calories worth of food energy in it. Or an egg, if you eat an egg, there's about 80 calories of food energy in here. But in the lab, of course, we're not going to use calories because we always have to use something different. And we're going to use joules. So we need to be able to convert back and forth. Now, it's a little tricky with the calorie thing. 1 calorie, and maybe you remember this from last year when you took biology. 1 calorie is the amount of energy needed to raise the temperature of 1 gram of water 1 degree Celsius. You might remember learning that. That's actually not the same thing as a food calorie. So that calorie that you learned about last year is a very small amount of energy, and that is equal to 4.184 joules. And joules is very often abbreviated with a J, sometimes a capital J, sometimes a small j. It doesn't matter, they're both the same. Calories, however, can get a little tricky because 1 kilocalorie, do you remember kilo? So a kilocalorie is 1,000 calories. 1 kilocalorie is a food calorie. And also, unfortunately, there's this ridiculous tradition we have that says if I make it a capital C, that tells you that I'm using a kilocalorie. So I'm sorry about that, but that's the way it is. Now, it's not the same thing with the joule. To capitalize the J on joule doesn't tell you anything. If you want to talk about a kilojoule, you have to say kilojoule. But with calories, there is this convention that is out there, so we will abide by it and hopefully not use it very much. But anyway, a kilocalorie is a food calorie, so if I wanted to say that this is 100 food calories, that makes it 100,000 of these calories, and it makes it 4,184 joules worth of energy in this orange. So let's talk about doing conversions. I am going to show you 2 different ways to do these conversions. One is the way that our textbook always did it. It's the way that I learned it, and it makes sense to me. But last year I had a student who was doing it a different way that I think is the way that some of you might have learned it in Algebra 1, and you might prefer to use that method. Either way, you'll get the same answer, which is good, because if we didn't, that would mean that one of the methods is wrong. So I'll leave that up there so we can have it to refer to. But let's say that you're told that you have 35 calories. And you are asked to figure out how many joules of energy is in 35 calories. So first we'll use my method. I would say 35 calories, and then I would multiply that times a fraction. And the fraction is going to be my conversion factor. And I would put 4.184 joules on the top and 1 calorie on the bottom. Now what this does, and this is the way conversion factors work, this is actually equal to 1. I know it doesn't look equal to 1 because the numbers are different, but because this amount of energy and this amount of energy are equal to each other, we really have the same amount of energy on the top and the bottom of the fraction. So we're going to change the unit on our number, but we're not going to change the value of the amount of energy, and that's the way a conversion factor works. And if you set it up right, this will cancel with what's on the bottom of the fraction. Because remember, if you have a number all by itself, it's the same thing as that number over 1. So if you want to think of it this way, you might want to do that. So when you're setting up an equation like this, you can set it up, make that into a fraction, use your conversion factor here, and make sure that this cancels with this. Because since I'm going to multiply across here and then multiply across here, if something's on the top and on the bottom, they'll cancel out. So I can tell from the way this is set up that I'm going to end up having to multiply. So 35 times 4.184. Oops, try that again. Is 146.44. And I'm left with joules. So that's the answer to that problem. Now, while we're at it, I thought I'd throw in another skill, and that is I want to go a little bit further with our discussion of significant digits. At this point, you know how to identify the number of significant digits in a given number. So right now, if you were to look at this, you would be able to say there's 2 significant digits in there, and there's 5 significant digits here. And one of our rules is that we can't have more significant digits in our answer than we have in the number that we started with. So I only want to keep 2 in my answer, which means that I can keep this place and this place, but I need to round it off. Now, I'm not going to round it off to 15 because 15 and 146 are definitely not the same thing. So I want to keep the same place values. I'm going to say that this is approximately equal to 150 joules. So see what I did there? This number has 2 significant digits, just like this one has 2 significant digits. And this is 146, and I rounded it up to 150, keeping the decimal point in the same relative location, but getting rid of this as a significant digit, and obviously getting rid of those also. So this is rounded off, and it's rounded off so that it only has 2 significant digits. And that's because I only started with 2 significant digits. All right, so let's look at the other method that sometimes people like to use for this, and maybe you'll find that this is the method you learned in algebra. So if you like this better, feel free to use it. And that is setting up a ratio. And the ratio says something like this. 4.184 joules is to 1 calorie. Okay, so we're starting with something that we know. We know that this is to this as x joules is to 35 calories. So it's the ratio method. 4.184 joules is to 1 calorie, as x joules is to 35 calories. We know that this ratio is correct, and so we want to make this ratio equal this ratio. So now we cross multiply, x times 1, and 4.184 times 35. Well, how about that? That's what we just did up here, 4.184 times 35. So mathematically, we end up doing the same thing. But if this makes more sense to you, if you like the ratio approach, then feel free to do that. So that is an example of getting from calories to joules. So let's try another example where we go the other way. And let's say that we're given 595 joules, and we want to know how many calories is that. And maybe while we're at it, let's review changing calories into kilocalories. So we'll say equals how many kilocalories. All right, so we're going to set this up using my method first, and then we can use the ratio method just so that you see both of them. So I'll start with 595 joules and put it over 1 just so that I have a fraction. And I'm going to multiply it times the conversion factor, and this time I'm going to put the 1 calorie on the top and the 4.184 joules on the bottom. So remember that this number essentially equals 1, not maybe numerically, but this amount of energy and this amount of energy is the same amount of energy. So I can multiply this times this without changing the amount of energy. I will change the number, but I won't change the amount of energy. And how do I know that calories go in the top? Well, because I want the joules to divide out, so joules are going to have to go in the bottom. So now you can see I've got a situation where 595 is on the top and 4.184 is on the bottom, so this becomes a division. So 595 divided by 4.184 equals 142.208. All right, so let's think about what we just said about significant figures. I was given 3 significant figures in this problem, so I'm only going to keep 3 in my answer. So that means that I'm going to say that that's 142 calories. And we'll put that up on the line. I didn't do that last time. So now if I want to convert that into kilocalories, remember kilocalories are 1,000 calories, so that's a bigger amount of energy. And it's bigger by a factor of 1,000, so that means that to convert this into kilocalories, I won't have as many kilocalories. I'm going to divide this by 1,000. That means moving the decimal point over 1, 2, 3 places, so that becomes 0.142 kilocalories, which would be a very small amount of food energy.